Now we shall see some examples for overlapping of pure orbitals. S and P, S and P are known as pure orbitals. And in my previous video, I already show you how sigma and pi bond is formed. So using these two ideas, overlapping of pure orbitals and the formation of sigma and pi bond of S and P orbitals, we are going to see few examples. Example 1, let's say we see hydrogen gas. How is the pure orbital overlapping the hydrogen gas? Hydrogen is 1s1, the electronic configuration. If I draw the orbital diagram, it has one electron. Okay. And if you look at the Lewis structure, it is H, single covalent bond H. So now we are going to show orbital overlapping. As students can see, this is S orbital. S orbital is spherical. So the hydrogen on the left hand side is a spherical. Hydrogen on the right hand side is also spherical, and that spherical will overlap with the the spherical on the left hand side. So, so this is the hydrogen on the left hand side, this is hydrogen on the right hand side, and the area that they overlap gives us a sigma bond. Okay, so important note, one single covalent bond represents one sigma bond. Okay, one single covalent bond represents one sigma bond. And please take note, the overlapping we already write just now as in our previous video. This overlapping is head to head overlapping, which causes the sigma bond. Now moving into second example. Second example, let's say oxygen gas. So the Lewis structure, oxygen, double bond oxygen, 2, 4, 2, 4. This is the Lewis structure of oxygen. Later you can draw. Oxygen is consists of 8 protons. So that is 1s2, 2s2, 2p4. We just consider the valence shell only because this is valence bond theory. So just consider the valence only. That is 2s and then 2p. And I hope students remember from our valence bond theory, overlapping occurs for the unpaired electrons. Do not consider the paired electrons because valence bond theory has to refer to the unpaired electrons, and in this case these two electrons. Okay, so we can check here. The unpaired electrons are located at p orbital. Okay, so another important things to take note here, double bond represents one sigma bond and one pi bond, totally opposite to single covalent bond. Single covalent bond is just sigma only. There is only sigma here. However, for double covalent bond, there is a sigma and there is a pi. So what we will do here is we use the first unpaired electron for sigma, the second unpaired electron for pi. So we draw the oxygen atom. Oxygen, double bond oxygen. We look at the left hand side oxygen. Remember that we are going to draw the p orbital. So first p orbital for the sigma from oxygen on the left hand side, and then oxygen on the right hand side we have drawn for sigma. This, that means we have to place this electron one electron here, and imagine oxygen on the right hand side have similar electronic configuration, valence electronic configuration, so it overlaps here. Therefore, we get the sigma. Okay, this area we get the sigma. This is oxygen on the left hand side, this is oxygen on the right hand side. Okay, that is settled with the sigma. Now we go to pi. Remember, pi overlapping is parallel, so we have to draw parallel orbital. One is like this, the other one is like this. Okay, this is for pi. So one electron is here for the left hand side, one electron here for the right hand side, this electron. And when they overlap, we get pi bond. So this is overlapping, this is called overlapping of pure orbitals for oxygen gas. Okay, so question might ask you show the overlapping of pure orbitals in oxygen gas, then this will be the answer. Okay, now we look at the third example, another classic example. The example number 3, nitrogen gas. Okay, for nitrogen gas. So when we draw the Lewis structure for nitrogen, we will get triple bond, and we get this as a Lewis structure. Now triple bond a bit different because triple bond consists of 1 sigma and 2 pi. So we can begin writing the electronic configuration 7. This is the electronic configuration of nitrogen. We just focus on the valence, that is 2s and 2p. 2s have paired electrons, 2p have 3 unpaired electrons. Based on valence bond theory, these are the electrons we are going to use for overlapping. And that is very clear because the first one we use for sigma, the second one we use for first pi, the third one we use for the second pi. That is for nitrogen on the left and right, both are same. So we start drawing the first one, the base, that is the sigma bond. Okay, oh sorry, not appropriate. Okay, and then this is nitrogen on the left hand side. This is nitrogen on the right hand side. So we pick this electron, the first one overlaps here, we get the sigma. Okay, we get the sigma. Then we move into the second one, that is this, to give a pi. Remember, sideways. Sigma is head to head. So, like this. One from the left hand side, one from the right hand side. Overlaps, you get the pi. So, settle the second one. Now, the third one is also parallel overlapping. So, what we do? We slant it to 45 degree, macam 45 darjah. So one I put on the left, one I put on the right because we have two nitrogen, left and right. So when they overlap sideways, sorry, we get a pi. So you can check here, students can check here. We have 1 sigma 2 pi, we have 1 sigma 2 pi. So this is the answer. Again, question will ask you to show overlapping of pure orbitals for nitrogen gas, and this is the answer. Thank you.